Section 7.2.11. Determine the total area under the standard normal curve for parts A through C. For each, be sure to draw a standard normal curve and shade the area that has to be found. So for part A, we want to determine the total area under the standard normal curve to the left of z, which is equal to negative 1.5, or to the right of z is equal to 1.5. So first thing we need to do is write out what we're looking for. What we're looking for is we want to be able to find the total area. And so the total area is going to equal the probability of z less than negative 1.5 plus the probability of z being greater than 1.5. So we're going to draw our bell curve. So if we draw our bell curve, okay, since we're given z-scores, we know that we have a mean of 0. And we also know that the standard deviation is going to be 1. And so now what we're going to do is we're going to locate where the z-score of negative 1.5 is located. And then here is where positive 1.5 is located. So we want to find the area here and then the area here. So what we want to do is we want to be able to find, okay, first part, we want to find the probability of z being less than negative 1.5. So let's find the area of that. So we want to look for negative 1.5. So we're going to go down and look at our chart here. And so we're looking for negative 1.50. So looking for negative 1.50, we can see that our area that's less than that number is 0.0668. So that's equal to 0.0668. Okay, now what we want to do is we want to be able to find the probability when z is greater than 1.5. So keep in mind that in order to find that, if it's 1.5 and it's to the right, we need to take 1 and subtract the area of the probability where z is less than 1.5. So we know that it's going to take 1, and let's go ahead and shade that part. So if we wanted to find everything to the left of this now, and so we're going to take 1 and then subtract what we get for the area to the left of 1.5. So what is the area to the left of 1.5? Well, we're going to go ahead and take a look at that here. So we're going to go to 1.5. So we're looking for 1.50. And we can see that that represents the area of 0.9332. So we're going to subtract the 0.9332. And so therefore the area now to the right, when we subtract that, is going to give us also 0.0668. So now what we're going to do is we want to add up those two areas. So we have 0.0668 plus 0.0668, which gives us a probability of 0.1 0.336. Okay, now let's take a look at part B. Here it says determine the total area under the standard normal curve to the left of z, which is equal to negative 1.68, or to the right of z is equal to 2.68. So again, we want to be able to find the total area and the total area is equal to the probability of z being less than negative 1.68 plus the probability of z, or the area, being greater than 2.68. So let's go ahead and draw our bell curve. Again, since we're dealing with z-scores, we know that our mean is 0. We also know that we have a z-score at negative 1.68. So we want to find the area to the left of that z-score. And then over here, we have positive 2.68, and we want to find the area to the right of that. So the first thing we want to do is we want to find the probability of when the z-score is less than negative 1.68. So let's go ahead and use our table to determine that. So let's take a look at negative 1.68. So here's negative 1.6, and there's 0.08. So from there, we can determine that the area, or the probability, is 0.0465. So we know that's 0.0465. And so now what we want to do is we want to find the probability of when z is greater than 2.68, which is going to equal 1 minus the probability of z being less than 2.68. So that means that this is going to be less than, so we're looking for the area here that's going to be less than that. So let's go ahead and take a look at our table again. And so we want to find 2.68. So here is 2.6, and then we're going to go all the way to 8. And so from there, we can see that we get an area of 0.9963. So we're going to minus 0.9963. And when we subtract, we get the following area to the left, which is 0.0037. So this is 0.0037, and this area represents 0.0465. And now what we're going to do is we're going to add them together. So if we take 0.0465 and then add 0.0037, then we get a total area of 0.0502. Okay, next what we want to do is we want to determine a total area under the standard normal curve to the left of z, which is equal to negative 0.92, or to the right of z is equal to 1.95. So what we're looking for is the total area, and that's taking the probability of z being less than negative 0.92 plus the probability of z being greater than 1.95, And again, we want to be able to draw our bell curve. So when we draw our bell curve, again, we're dealing with z-scores, so we know that the mean is 0. We know that we have negative 0.92, and we want to find the area to the left. And then we also have 1.95. We want to find the area to the right. So let's first find the probability of when z is less than negative 0.92. So let's take a look at negative 0.92. So we have negative 0.9, and then we're going to go to 2. And we can see from here that the area to the left is going to be 0.1788. So we know that that area represents 0.1788. Okay, now what we want to do is we want to find the probability of when z is greater than 1.95. So that's equal to 1 minus the probability of z being less than 1.95. So that means that we want to find the area that's to the left of this. So let's go ahead and do that. So we're looking for 1.95. So here's 1.9. Go to 0.05. And then we can determine that our area there to the left of that z-score is 0.9744. So 1 minus 0.9744. And what we get when we subtract that from 1 is we get the area of 0.0256, which means this area is 0.0256. So now in order to find the total area, we're going to add up 0.1788 plus 0.0256, which gives us a total area of 0.2044. Okay, now that's by using the table, so let's go ahead and do this by using the TI-84 calculator. So if we want to use the TI-84 calculator for the next part, let's go ahead and do that. So using the TI-84, we're still going to use the normal CDF with the lower bound and upper bound. But in this scenario, for this one, we might have to look at this a little bit differently. Okay, we need to find the area of the middle, okay, and then we're going to subtract 1 from that to get the areas on the ends. So we can either do two things, and I'm going to show you two things. So we can find we're going to take 1 and then subtract the area that is in between negative 1.5 and positive 1.5. Okay, so we're going to come in here, we're going to take a look at the calculator. All right, so we're going to take, we can say 1, and then we can subtract. Okay, we can go to second distribution. We want normal CDF. So we want to find the area, so the lower bound, okay, so the lower bound in this case is going to be negative 1.5. The upper bound is going to be positive 1.5. We know that our mean is 0 and the standard deviation is 1. So we already have 1. We're going to subtract normal CDF, negative 1.5, comma 1.5, comma the mean, and then the standard deviation. And then that gives us 0.1336, which is what we get here. So we get 0.1336. Now we can also look at this as another way. okay, we know that if this is negative 1.5 and that's 1.5, it gave us two of the same areas. So basically, instead of doing that, or we can take the probability of negative 1 point, of the probability of z being less than negative 1.5 times 2. So we're going to take 2 and then multiply that by the normal CDF, where we have negative 9999, negative 1.50, and then 1. So let's go ahead and do that. So if we take 2 and we multiply it by the normal CDF, where our lower bound is negative 9999, our upper bound is negative 1.5. Again, our mean is 0, standard deviation is 1, and we get, again, the same value. So that gives us the same thing. And over here, I forgot to put in the normal CDF at the front of it. So you want to make sure you use normal CDF. Okay, so therefore that gives us the first one. All right, now let's take a look at this next one. Okay, so if we want to again use normal CDF, okay, we're going to take 1. And in this case, these two numbers are not the same. So I can't do the multiplying it by 2 because they're not the same. So we're just going to find the area in the middle and then subtract it by 1. So we're going to take 1 and then subtract normal CDF, where the lower bound is negative 1.68. The upper bound is 2.68, which that gives us the area in the middle with a standard deviation of 0 and a mean of 1. So let's go ahead and do that. We're going to take 1 and then subtract second distribution normal CDF. And then we know that our lower bound is negative 1.68. The upper bound is 2.68. And then our mean is 0. And then we can see that our standard deviation is 1. And then hitting enter, we should get the same area down there, which is, rounding it to 4 decimal places, is 0.0502. So 0.0502. Okay, and then likewise here, we're going to take 1 and then we're going to subtract, again, that formula, which is normal CDF, and the lower bound in the middle is negative 0.92. The upper bound is 1.95 with a 0 and 1. So let's go ahead and do that. So we take 1 and subtract, again, second distribution, go to normal CDF. We have negative 0.92 for our lower bound. Our upper bound is positive 1.95 with a mean of 0 and a standard deviation of 1. And when we hit enter, we should get the same. Here, we're going to get 0.2044. Rounding it to 4 decimal places gives us 0.2044. Okay, now we're going to use Statcrunch. Okay, so let's go ahead and use Statcrunch. So when using Statcrunch, okay, we're going to go to Stat, select Calculators, and scroll all the way down to Normal. Okay, then we're going to go to Between. So for the first one, we know it's going to be between negative, well, we want to find the area that's in between here, and then we need to subtract 1 in order to figure out the areas that are blank. So if we put in negative 1.5 and then 1.5 and then select Compute, okay, so in order to find the area, okay, if we take our the area that's inside, okay, and so what we're going to do is we're going to subtract the area in the red. So if we take 1 and then subtract 0.8663856, well, that's going to give us 0.1336. Okay, likewise, if we come down here, we want to find the area that's in between. So if we take a look at the two scores, which is z is negative 1.68, and then to the right is 2.68. And then therefore, again, if we take a look at this area, okay, and again, if we take our 1 and then subtract 0.94984023, that's also going to give us 0.0502. And then likewise for the last one here, if we use our normal calculator, we know that our lower number is negative 0.92, and then the upper number is 1.95, and again that gives us that area. So once we find that area, then we're going to take 1 and then subtract it. So we take 1 and then subtract 0.79562556, and that's going to give us 0.204.